question with the format.
Yeah, format. Let's start with that. Good question. So format will be multiple choice. It will be what I call short answer. And short answer is all verbal, meaning written. So I might ask you to explain something or discuss the difference between speed and velocity, right? Something where you'd have to physically make a statement about it. Now, with short answer, with your statements, if you utilize an example, that's fine. You could say, well, this is this and this is this, as seen in this example, or as seen if this happens. So if you want to use values, use diagrams, use examples to explain what you mean, that's fine also. And then finally, mathematical. Okay? Some people say long answer, same thing. So it's all math-based. So the last part will have all math on it. So it might be equations. Now for this first test, because it involves your summer packet, there may also just be math problems like find the missing angle, find the missing side of the triangle, and right triangle trig plays a role. Or maybe it's a system of equations and I have you solve for x or y. Again, this is the one time where you'll have math outside of physics on the test because it will have half summer packet and half 1-3 through 2-3. Okay? Generally, percentage-wise, to give you an idea, it's usually 30, 30, 40. Okay? Usually. I have not made your test yet. Okay? I will make it tonight. So I'm not sure if that's going to be the exact percentage, but it's usually around that. Sometimes I'll have a little heavier multiple choice on days when we have B days. Because clearly for B days, we have less time, right? So on a day where there's a B day, I might put one or two more multiple choice, which makes that go up to like 35% and reduce the amount of math problems because those you have to show more work and they're a little bit longer. And because a B day is a shorter day, it makes more sense. So it can vary, but that's the general scheme that you'll see for setup. Go ahead. Spence. Go ahead. Number 32 on 2-3. Hold on, let me just... Why is that doing that? Okay, there we go. Number 32. Do you know what page it was by any chance? 50-something, right? Thank you. It says refer to the graph. So I'm going to quickly sketch the graph. All right. 32 says, referring to the graph in problem 30, which I've shown here, I'll give numbers in a minute. What is the average velocity of the tennis ball from 0 to 5 seconds? So this is a great example to ask. We've got, this is 2 seconds in, this is 3 seconds in, this is 5 seconds in. Our heights are corresponding to a height of 1, a height of 3, and a height of 2. Okay? I've only given the numbers that apply to the points. Normally I would give 1, 2, 3, 4, 5. Agreed? Yeah? Okay. So when I look at this problem, I can think first about this region right here as its own velocity if I calculate the slope. And again, this is a position or a displacement versus time graph. On a position versus time or displacement versus time graph, I know that this is how far I've moved, which is 2 meters, in how long? 2 seconds. So this velocity in this little piece is -1 meters per second. That's what the velocity would be for this section right here. Because again, why is it negative? The slope is negative. Or I think of this as a person starting at 3 meters, which is here, and walking backwards 2 meters, right? Backwards 2 meters from 3 to 1 in 2 seconds. So I just demonstrated that from here to here. Now I'm at 1 meter. Let's call this 0 meters right here. I'm at 1 meter. I got to move to 3 meters. 3 meters in another 1 second. So I got to go back to 3 meters in 1 second, which is a higher speed and a positive velocity as well. So here, the object, or me in this case, moved 2 meters in 1 second. Up 2 over 1 is a slope of 2, and that's a positive slope of 2 meters per second. So -1 meters per second, positive 2 meters per second. So already I know that even though this was negative, if I think about the word speed, remember speed does not care about direction. Which of these is a higher speed? It's 2 meters per second. If this had been -3, this would have the higher speed. again, even if this had been negative, if I asked you which has a higher speed, -3, even though it's moving backwards, you think of it as a more negative number, speed doesn't matter direction. So this would have a higher speed if it were -3. The last part, I would do the same thing. I would drop 1, go over 2. So that's a slope of -1/2. But unfortunately for this problem, it doesn't ask me for the velocity in these 3 ranges, right? So that's what makes this one a little more difficult. And unfortunately, we can't just average these 3 together. The common mistake is to take the 3 numbers, in those 3 sections, and average them. Why can't I average them? Why can't I average them?
You'd have to do a weighted average because for like the second, the third segment of it, that's 2 seconds, while the other ones are 1 second each. So it'd have to be weighted.
Yeah, backwards, but same idea. This is only a 1 second time period, whereas these are 2 second time periods. So I can't just take these 3 numbers and average them. It doesn't actually work out. So instead, what can I do to find the average velocity from the first point to the last point? What can I do instead? What can I use? What line? We talked about this line. Do you remember now?
Yeah, you would just take
Of the?
I forget the word, but
The line of best fit.
Not the
You
line of
just
best
take
fit.
the first point and the last
The
point.
secant?
Listen to Daniel, louder.
The secant?
The secant line. Remember it's called the secant? So if you connect any 2 given points on a curve, and this is not necessarily a curve, I know it's a linear piecewise function. If you connect any of them, you get what's called the secant, and the secant always represents the average velocity from A to B. Okay, so I would see that this is a decrease of 1 over a time period of 5 seconds. So my average velocity is -1/5 meters per second. And this is, again, for the entire situation, from 0 to 5 seconds. I just put 0.5 there. The average velocity from 0 to 5 seconds, again, is a decrease in height of 1 meter and an increase in time of 5 seconds. So -1 divided by 5 meters per second. So -0.2 meters per second or -1/5 meters per second. So again, what does that mean? It means that I move 1 meter in how long? 5 seconds. It's very slow. But again, this person, they changed direction. They started over there, right? They walked back, they then jumped, and they walked pretty slowly back to here. But in the end, you went from here to here, and it took 5 seconds. Okay? Or in this case, sorry, you went from 3 to 2. So from there to here to here, in 5 seconds. Gigi.
I'm kind of confused on how you got -1.
So I just did the slope of that red line. So take a look at the red line. It goes down 1 unit. That's the change in the vertical component, right? Slope is the change in the vertical over the change in the horizontal. So I went down 1 unit, which puts me in line with this point I'm ending at. And then I went over how many seconds? 5 seconds. So remember, slope is the change in vertical over the change in horizontal. I can complete the triangle to show you that. Take a look. Complete the triangle here and here. Okay? That's a decrease of 1 meter in a time duration of 5 seconds from start, which is here, all the way to finish, which is over here on the far right. Chris?
How would the average speed be in this? So instead of like, could we do like an example of average speed in this problem?
You could. And to get the average speed, you would have to use what we called a weighted average, what he was referring to a minute ago.
Right.
So we would have to figure out the total distance traveled and divide that by the total time. So we'd have to disregard the negative signs everywhere.
Right.
So how far did this guy travel in the beginning, Chris?
Oh, well, he went -2 in
But
2 seconds.
in
but
distance.
Yeah,
Because
distance.
he's asking about speed, so I said we have to use distance now if it's speed. So
it's
this
just
person
2.
traveled 2,
2 and
then
2
they traveled,
2.
and then they traveled.
1.
So how far
it's
distance?
5.
5 meters is the total distance. Again, ready? 2 units back, 2 units forward, and then 1 unit back. That's a total of 5 meters in distance over 5 seconds. So what's the average speed?
1. So speed's
The average speed in this problem is 1 meter per second. Again, speed is indicative of distance, not displacement. So although I'm moving backwards, and we say, oh, that's a negative displacement, for distance, it's a positive value. So this person moved 2 meters, 2 meters, and then 1 meter in a total of 5 seconds. 2 plus 1 is 5. Divided by 5 is 1 meter per second. Daniel?
Does our calculator need to be in radian or degree?
Degree.
Okay.
If you're checking your calculator mode, you hit mode, it should be on degree always for this class. in your math course later in the year, you're going to put it to radians, so know what it's on for your tests.
So basically, like, velocity is always corresponding with displacement. You're going to use the displacement, and the speed, you're always going to use the distance.
Absolutely. Yep. They're analogous. I use the phrase.
Right.
Wait, so to calculate the displacement for this,
Just start to
Start to
finish.
finish, yeah.
How far did the person go?
oh, and then distance would be calculating each one of these segments.
2 meters? 2 meters? 1 meter. But not including the negative sign when
Yeah,
talking
it
about
would still be,
distance.
it would all be positive. And then,
Because think about displacement as negative 2 meters, right? Because it's coming down. Positive 2 meters, those cancel, don't they? And then the last piece is down 1 meter. That's the negative 1 meter in 5 seconds.
and then when you take the slope, that's how you find speed. And then if you want to do
When you take the
displacement,
slope, is how you find the velocity. Slope of each segment gives you the velocity of each segment. The slope of the red line from beginning to end gives you the average velocity of the whole thing. Speed is distance over time. And this is 2 meters distance, 2 meters distance, 1 meter distance. That's 5 meters of distance in 5 seconds, which makes the speed 1 meter per second. Okay? Again, know your definition of speed. It's distance over time.
And then
Distance doesn't care if it's negative or positive. You always take the positive for whichever way you move.
And then velocity would be displacement over time.
And that's what this is.
Right.
The
The
final
meters,
displacement, this person started at 3
Right.
and they ended at 2.
So yeah.
So it's a displacement of negative 1.
Right.
And the time is positive 5 seconds. So negative 1 meter displacement for 5 seconds is negative 1/5. Good questions. I'm going to sit. I could point on this thing too. Next, what do we got? I don't have to do this every time. There we go. Yeah, go ahead, Tom. What do we got questions-wise next, guys? Questions? It could be theoretical. Yeah, go ahead, Gigi.
21 of the problem set?
21. This is on page 53.
Yes.
Okay. Let's take a look. Suppose you ride a bicycle around the block and return to your starting point. Okay, that's what I'm visualizing, right? And return to your starting point. At the end of your trip, is your average speed greater than, less than, or equal to the magnitude of your average velocity? Now, before you give an answer, help. In class, we talked about this and we used the less than or equal to sign, and we used an inequality statement to discuss. So, before I even get into the problem, we made a statement earlier, and if you want to jot this down, it might be useful, that your speed, in general, average speed, is always going to be greater than or equal to your average velocity. So based off this statement alone from class, the answer is speed. But let's prove that true, Gigi, okay? So if I think about this, if I start here, and let's give lengths. If I start at the beginning and move around and end up where I start, what's my displacement? What's my displacement, everybody?
0.
Yeah, because I ended up where I started. Remember, displacement is the difference between your initial and final position. But my distance in this problem is the sum of those lengths.
12.
Yeah, because this person walked 2, 4, 2, 4, which is a total of 12. So in this case, the speed is going to be 12 meters over whatever time it took, whereas the velocity is 0 meters over whatever the time it takes. I don't know how long it takes, but it doesn't matter because my velocity is 0. So the speed has to be greater than the velocity. Can you see that? I'm going to slide it up a little bit. Hold on. If you're in the back and you can't see the bottom, let me know. Okay? The speed is going to be some number over the time period, whereas the velocity is 0 over that time period. So in the end, no matter what the speed turns out to be, it'll still be greater than the velocity. And again, that's this statement up here. Oops. That's this statement right up here. What's the other statement that we made? We compared speed to velocity. We also compared two other things.
Displacement and distance.
Yeah, do you remember which was bigger than the other? Use this problem. Yeah, and just exactly, look at this problem. Clearly, look what I just circled. The distance is 12, the displacement is 0. So that's another rule we can write down, is that distance is generally greater than or equal to displacement. And we could use absolute value. I don't think I put them in class, but it is important to use absolute value there, actually. All right. Another question. What else are we struggling on? From homeworks, from class notes, from the problem set, for those that read the textbook, is there something you read that didn't make sense? I mean, in the past, I'd say 10%, 20% of kids read the textbook. If you could read it, I think it would help. If you find that like you're doing great with class lecture and videos, that's fine also. But if you need to supplement, reading is useful. Chris, and then we'll go to Daniel.
Can we just go over number 8 on 2-1?
So this is number 8
In the
on
homework?
Yeah, no,
page 47.
on the
Page 47, number 8. Can you read it, Chris? Just read it to the class. My voice is kind of...
A billiard ball travels 22 centimeters in position in positive direction, hits the cushion, rebounds in negative direction, and finally comes to rest at 7.5 centimeters behind its original position. What is the distance covered by the ball? What is the displacement of the ball?
So it rebounds off the wall and recovers 7...
Finally comes to rest 7.5 centimeters behind its original position.
Okay. So
I
I
was
just...
confused,
Yeah, good.
I was just confused, like on the problem set, how to give like the formula for that.
Yeah,
Like,
so...
just kind of just do separately, because like also on the notes I had the change over x like equals initial and final, so I kind of like try to use that.
Yeah, so you could...
Like,
It's a good question. You can use a formula here, or you can look and inspect the problem. Okay, so if I think about total distance, I add up the positive values. So in this case, since the ball ended 7.5, is that the right number? No, I shouldn't. Sorry. Since the ball ended 7.5 behind where it started, that's a distance of 29.5 from the bumper. So here's the bumper itself in billiards. So the pool ball travels to the right, 22, comes back, ends up 7.5 beyond where it started. That's what it said, right?
yeah.
So if I want the total distance, I sum them together. Okay, so that'll give me 51.5 is the distance. So distance is always the sum of the values or the length you've traveled. Go ahead, Michaela.
So would the displacement be 7.5?
Yeah, but because it's behind the ball, what sign do we apply to it?
Negative.
Yeah, very good. Okay, so in this problem, although it is tempting to use a formula, I would also do it by inspection. Just because what I'm seeing here is that I started here and I end up behind where I started. So as a result of that, since I end up behind where I started, my displacement has to be negative. Okay, now what I could do also is I could apply a positive sign to this, apply a negative sign to this, and just add them together. And you'll get negative 7.5. Lucy, then Alex.
I did 20, I multiplied 22 by 2 and then added the 7.5.
For distance,
Yeah.
that works. You should still get 51.5, right?
Yeah.
Yeah, that's
So you
work.
can do that?
Cool, because you think what you're doing. You're doing 22,
And then that.
22, and then 7.5. You're just truncating it or breaking it into smaller pieces.
Okay.
It's fine. Yeah. Alex?
Wait, but I'm like really confused. If it only goes, wouldn't it be 29 for the
Where you at?
distance?
So it starts here, Alex. It goes 22 to the right,
Yeah.
and then it comes back 29.5.
I feel
Distance
like
doesn't-
only 7.5.
It says it ends up 7.5 behind the
what I was
original
Oh, that
position.
makes sense.
That's what that's
So
why I messed
this
up.
was the original
Oh,
position,
then I get it.
not 7.5 behind the wall.
Yeah, that's what I did.
Okay?
The more
That's right.
thing. Just tell me.
Hey, listen, it is so much better to make a mistake on your problem set than on the test. The same mistake on a test is worth 4 times as much as your problem set. Problem sets are 15% in this class, right? Homework and problem sets. Tests are 60%. So make the mistake now on your problem set, maybe you lose a tiny bit of points. On the test, that's worth 4 times as much when you think about it numerically. So don't worry about making small mistakes now. Fix it for the test. Alex.
How much is it? Like, how many homeworks is one problem set?
It depends on the problem set assignment. Every problem that you answer on the problem set, I value as 1 point. A normal homework on a nightly basis is worth 5. So since you guys you've turned in 1, 3, I give you credit for the syllabus. That was kind of nice. Summer packet, 2, 1 to 2, 3, and 2 worksheets. You've had 30 points worth of homework so far. And the problems that you turned in, how many questions were there approximately? 10 or 12 you answered, right? So that problem set is probably going to be worth around 10 to 15 points if there's A and B in some problems. So you've done about 30 points of homework, and this last problem set you're turning in is about half of that credit. Yeah, and the homework you turn in is usually 5 out of 5 if you do it, if you complete it. But some people are getting partial credit because it's not fully completed or it's late. So it depends on you as a student. Daniel had the next question. Did you have one ready, or do you want to?
I forgot it.
Okay. Think about it. Yeah, that's fine. What's next? What else?
Oh,
Yeah.
on the mathematical part, will there be like a
Formula sheet?
no? I meant like a conversion table.
Okay. So conversions. If it is something outside of prefixes, I will tell you the number. So you need to know, though, that 1,000 meters is a kilometer, because your prefix for kilo means 1,000. You need to know your prefixes that are highlighted that day and what they mean. So being able to convert within the metric system, you have to do. So centimeter to meter, millimeter to meter, kilometer to meter, all of those conversions you have to be able to do yourself. But if I give you a problem and it says, convert 10 centimeters to miles, I will give you centimeters to inches, inches to feet, feet to miles. I'll give you all those conversion factors that you need to know to convert amongst units that are different. Or if it's gallons to liters or whatever it may be. Like the worksheet, remember I gave you a little cheat sheet at the top on the worksheet? So I would give you that if you needed to convert units such as those. Okay? Now, I know some of you know this already, so I'm going to make it clear so it's known. You can check your unit converter on your calculator. There's a way to do it. But if you do your work on the calculator and don't show anything, you're not going to get credit for the problem. I want to see the steps that show the conversion. I know it's simple right now. Trust me, I get it. Converting meters per second to kilometers per hour is not difficult at all. But it will become much more difficult as the year goes on. We will convert things that are much more complex than simple velocities. So I need to see the work for conversions. So if you're going to check your work on your calculator, by all means check it. That's fine. But I want to see the steps. I want to see the cancellation of units along the way. The converter, if you want to know where it is on your calculator, is under apps. And some of them have it, some of them don't. Yours doesn't have it here, unfortunately. I don't think you need it, but if you wanted to use it, it's under apps. And then if you go down to side tools, God bless you. Some calculators have it, some don't. Some people may have just cleared their RAM, so you don't have it on there anymore. So if you at some point in time just erased your whole calculator, you might not have it under apps. You don't need it, so if you don't have it, don't worry. Okay, but if you want to get it, you can connect a cable at the bottom here to another person's calculator that has it, and you could use what's called the link feature here, second link, and you could transmit, you can send and receive programs. Okay, if you're really worried about it and you really want to have it, come see me on your own time and I can show you how to do it. That's fine. Okay? But I'm not going to go through the process now.
What was it? Apps and what?
And then
Side tools.
Oh wait, side tools. Yeah.
8 days.
Oh, unit converter.
Mm-hmm.
Oh, that's so cool. I didn't see that.
Yeah, you can use it to check your answers. It's fine.
it's under apps, and then you go to side tools.
If you're going to practice it tonight, if you're gonna practice the side tools tonight, I'm going to give you a little hint. The answer that side tools gives is always in scientific notation. So it might give you an answer that says 1.08 and then capital E2. That means 1.08 times 10 to the second. Or it might say 1.5 E negative 4. It means 1.5 times 10 to the negative 4. So recognize that when you use the side tools thing, it's always in scientific notation. So don't confuse yourself tonight and be like, it's not the same thing I got. Make sure you recognize it's in scientific notation. Practice it. Don't come into the test tomorrow and assume you're going to be able to use the scientific tool to check and then ask me during the test. I will not answer questions on how to use your calculator on a test. Before that, by all means, I'm a calculator guru. I'm happy to help you with anything. But on the test, I answer no questions on calculators. The only question I ever answer on a test, honestly, is, hey, Mr. Howell, there's a typo, and I'll come over and look if there's physically a typo, okay? Or if for some reason I made the choices A, B, B, C. For some reason it did it out of order. That's fine, let me know. But I don't answer questions like, I don't get it. What does the wording mean of this problem? I'm not going to answer those questions. It will not happen, okay? Gigi. I will give it to you guys in the first period, because if I give it to you in the second period, the whole first period, you're going to be thinking about the test and not what we should be focused on. So I will give it to you in the first period, okay? It's rare that I have tests on double periods, but it happens. It happens sometimes, and clearly you guys know that. It's going to happen tomorrow. Okay? Other questions? We have till 12:12, so we have 14 minutes still. All right, it's a B day? It's a Bex day or something today, right? Yeah? Gigi? Or, sorry, you asked one already. Let me go to Dan, then I'll go to Gigi. Prams?
What was the answer to
51?
57 question. It's like, I think it was the volume.
Yeah.
Number 51.
Yeah.
Sorry.
Yeah, huge answer. Yeah.
Hold on. What are we on? What page or what section?
It's 1-3.
Oh, 1-3.
1-3, yeah.
1-3, number 51.
1.3 times.
See A2 at the back of the book.
Cheers.
Hold on. Can somebody tell Dan what they got and just talk amongst each other? I'm going to check the answer in the back half.
Million.
I got
I got
1,385,000,385.
1.38 times 10 to the 13th power.
928,400 centimeters cubed.
You have to do like centimeters.
You have to multiply 631 by 34 and then multiply it by 646.
And then you get that in meters, and then you gotta.
Then you
add
gotta,
two
yeah, then you
zeros
gotta,
for the-
yeah, exactly, you gotta do it to centimeters because you have to use centimeters cubed.
All right.
Good.
So the exact value in the back of the book for 51 is 1.4 times 10 to the 13th cubic centimeters, or centimeters cubed. 1.4 times 10 to the 13th. Clearly that's rounding to the nearest tenth. So if you had 1.3 something something, it's probably the right answer, okay? So 1.4 times 10 to the negative, 10 to the positive 13th. Prams, you want to go over that or you feel comfortable? Okay. Gigi, go ahead.
So I also have a question, but how'd you get into 13?
Yeah, I have 1 billion.
Yeah, I
We'll
got.
take a look.
Like to the 10.
I got to the 13th.
Okay.
Would that be trillion?
So here's the concern, ready? First of all, how do you find volume?
Just multiply all three.
LWH, right? So here's the thing. If you multiply your 3 lengths in meters first and then convert, you have to do a weird conversion. I'll show that. So if you want the right answer for a problem that if you're going to change a unit and then utilize that number in a arithmetic operation like multiplication, you should change all 3 units first to centimeters, then multiply them. If you multiply it out first, the conversion has to go from cubic meters to cubic centimeters, which is not the same as going from meters to centimeters. Okay, that's why. Because it's cubic meters.
Oh.
It's cubic. M.
So you would have to cube the 100, right?
Correct. You'd have to cube the conversion factor. Let me show that.
But if you do
If you convert earlier to centimeters, then multiply all 3, you're fine. But what did you get, Dan? Can you tell me the number before you converted in cubic meters that you had? You got a volume?
Yeah, it was I get 13,859,284.
Yeah.
Okay, so take a look, please. Take a look. Now, watch what I'm going to do. For this problem here, if I want to convert from meters to centimeters and they're cubic, I have to do this. See what I'm doing right there? I have to convert cubic units. So as a result, how many centimeters are in a meter normally?
100.
100. So what I need to do is this. So what I have to do physically is cube the top and bottom to get the units cubed. See how I put my parentheses? I tried to sneak it in here. I need to cube 100 centimeters. I need to cube 1 meter. So it's really 100 centimeters, 100 centimeters, 100 centimeters times this, which is where you're getting to the 13th, not the 6th. Okay? That's a different kind of conversion that we didn't actually go into with volume. So I would consider this, personally, if I have a unit, the unit itself that is squared, I would have to recognize that I need to have it squared. If it's cubed, it has to be cubed. So use the standard conversion factor and then square the whole factor or cube the whole factor itself.
And the easier is just to convert.
The easier is to convert earlier and then do it, but that's 3 steps of conversion. So I would do it this way and then put a cube factor on the outside of your conversion. Okay? Again, because you're converting cubic units, not just units. Very good question. What else? What else? Chris,
Can
good.
we go over section 2-2,
What number?
number 23? It's like the space.
Number 23, this is on page, hold on. Thank you. Okay. Number 23, radio waves travel at the speed of light, approximately 300 million meters per second. How much time does it take for the radio message to travel from the Earth to the Moon and back? And back. So you have to double the distance from the Earth to the Moon before you use it. Is that clear what I'm saying? The radio wave is here on the Earth. Here's the Moon. The radio wave is going to travel, hit the Moon, and then come back. So my distance, because I have to use distance here for time, my distance traveled is double the original distance.
And so that would differ your answer if you just multiplied the conversion at the end. Because I did.
What's the distance, first of all? Did you look it up in the back?
Yeah, it's 3.8 times 10 to the fifth. So it's. I mean, I put it into
centimeters.
Well,
I mean kilometers.
it's given in meters or kilometers?
It's given what the distance.
What is the distance given in?
Um.
You guys looked this up in your book.
I looked at it was in.
The speed is given.
It was kilometers, but I put it into meters because it was meters because the speed is.
So is
meters
that
per
the correct
second.
thing in meters?
Meters per second is I had 384 million.
Wow.
So is this number, should this be? Thank you. That's what I'm asking. Okay.
Yeah.
So
Now-
I just put it in meters because right, it's meters per second.
This is
I
the
think multiply that by 2 so you're going there and back.
Oh, sure. No, you're right.
Okay. Now, you would have to double it. I think I actually helped some people after school with this problem, and I probably didn't even say to double it there because I didn't even read the question. You're going to the moon and back. Okay, so double it, please. So speed equals distance over time. My distance is in kilometers, so I have to multiply that by my conversion factor of 1,000 meters for every kilometer. Kilometer cancels with cancels here. So this becomes 3.8 times 10 to the 8th. But I have to double that, which is 7.6 times 10 to the 8th. Again, I'm going to multiply it by 1,000, so it's 3.8 times 10 to the 8th now. That's my number. But I have to recognize I need to double it, so the distance is really 7.6 times 10 to the 8th. I'm looking for time. How do I solve this formula on the bottom? How do I solve this formula on the bottom for time?
Switch them.
Danny?
The 7.6 times 10 to the 8th over 3 times 10 to the 8th.
Good.
The units.
So that's all right. So 7.6 times 10 to the 8th in meters over 3 times 10 to the 8th meters. By the way, that's 3 times 10 to the 8th, 300 million. 3 times 10 to the 8th meters per second. So Danny, how did you solve for t though? That was my question, the formula.
For t, I just converted it to scientific notation.
No, here. How do you solve this formula for t? Right here. You have t by itself, right? You said t is equal to d over speed. Where did that come from? What did you do? How did we solve this formula? I was asking, so we...
Well, because it's on the bottom, you assume that speed's over 1, so you can just switch the two.
So move this
So
up
move it up.
and move the speed down. Remember we talked about this in class? So I'm just asking you the derivation of the solution here. So whenever you're trying to solve an equation that has 3 parts to it, these can be switched. So these two are going to be switched here, which gives us time equals distance over average speed. Okay, we switch those two. We plug in for distance. We plug in for speed. We get the overall time. What does the number turn out to be, Danny?
I got 2.56.
Seconds or what?
Yeah, seconds.
Seconds? Okay. And again, if you got an answer of 1.28, it means that you just didn't double the distance. A lot of people probably got 1.28 for this. It means that you didn't consider the fact that the signal is going there and back. So you could have done the time to go there, and then what?
And then
Just double the time also,
doubled the
and that's
time.
fine.
I thought that was-
I showed doubling the distance. It's again 6 1/2 dozen. Doesn't matter. It's the same thing. Gigi?
How'd you get 7.8 times 10 to the 8?
So take a look up at the top where I had distance there. You see the distance was 3.8 times 10 to the 8? Did you see that part? Because I'm going there and back, I just doubled. What's double 3.8? 7.6. You don't have to double the 10 to the 8th, you know, right? So take a look. I'll point to it here. Let me point. Right up here. See what I'm pointing to? That was the actual distance from the moon to the earth. So to double that number, I only have to double the first part. You don't double this part also. So doubling 3.8 is 7.6. Because I'm going to the moon and back. Okay? Again, you didn't have to do that though. You could have used 3.8 times 10 to the 8, guys. That's fine. If you use that, you'll get the time for the trip one way, double the time then. Same difference. Keep going. What else?
I think 26A.
26A. This is on page 56. Number 26, part A. A rose-covered parade afloat is at x equals 0 at time equals 0. The float moves in a straight line at 2 meters per second for 5 seconds, comes to rest. After a 5-second rest period, the float moves again 1 meter per second in the same direction as before. Sketch the position time graph from 0 to 15. All right, so let's do this. A great example. Great example. Like, perfect example. All right. So at time equals 0, it's at 0. We know that. We're told that it moves at 2 meters per second for 5 seconds. 2 meters every second for 5 seconds. So let me put 5 seconds right here. And it's moving at 2 meters per second. So how much ground does it cover? 10 meters. 2 meters a second for 5 seconds. It means it's going to go 10 meters. So there's my next point right there. Okay, I connect these. And again, look at my slope. Up 10 over 5. That gives me a velocity of 2 meters per second. So the first part is good. Then it says there's a 5-second stop. What does that mean I do for the graph if it stops for 5 seconds, Alex?
It's a straight line.
Yeah, it's a horizontal line for 5 seconds. And we're there. And then finally, the last part says the float then moves again at 1 meter per second. It doesn't say for how long, but part 8 says to go up to 15 seconds. So let me extend my axis a little bit here. Let me go all the way to 15 seconds. I'll try to make it proportional. And I know that I'm moving at 1 meter per second. 1 meter per second for how many seconds? 5 seconds. So how far have I moved? 1 meter per second for 5 seconds means I moved 5 meters. So if I'm at 10, where am I going to finish at?
15.
So make another tick mark at 15 meters. And put your coordinate there. And connect. So which piece had the greatest slope? Piece 1, piece 2, or piece 3 in that order? Gigi?
This one.
Piece 1. Because piece 1 we're traveling at 2 meters per second. And the slope of this curve or this graph represents the velocity. Remember, the slope in each section represents the actual velocity. So it's 2 meters per second, 0 meters per second, 1 meters per second, or 1 meter per second. Okay, this is number 26, part A is the question we're looking at here. Could we have found out the overall average velocity for this one? Sure. We could have connected here to here, and that would be 15 meters in 15 seconds. What's the average velocity for this problem? 1 meter per second. And it makes sense. Ready? It's not a weighted average anymore. This 2 meter per second takes 5 seconds. 0 takes 5 seconds. What's the average of 2 and 0? 1. And then the last part, what was the speed? Also 1. So if I wanted to do an average here, I take 2 plus 0 plus 1, which is 3, divided by 3 time periods. We're looking at 1 meter per second. Okay? So again, the average in this case happens to be the exact same thing as the average of these 3 numbers because each segment is the same duration. Okay? Please feel free to email me any questions you might have in addition. Okay?